for today's warm-up, you're going to make each one of these expressions into something plus or minus something. Okay? Each one of these is going to be something plus or minus something. We've already been doing this when we've been changing variables and equations. I'm going to have you practice the division part to start here. Everybody sees that these are all division problems, I hope? Yes. Okay, let's go. So let's take a look at these equations. 4x divided by 2 is 2x, and negative 10 divided by 2 is negative 5. Okay? For number 2, 1 divided by negative 2 is negative 1/2. Negative 50 divided by negative 2 is 25.
Isn't it a negative?
Nope. Negative divided by negative is positive. For the next one, there's actually 2 ways to go about this one. I'm going to choose to do my 5 divided by 25. You could distribute, but I'm going to do 5 divided by 25 to do 1/5. And then I'm going to distribute to get 1/5 x plus 2. Either way, if you distribute first and then divide both things, you get the same answer. Yeah?
Can it also be 0.25x plus 2?
It could be 0.2. But I'm going to encourage this because we're going to be acknowledging this number as slope. And it's much easier to say go up 1, right 5, than to say go up 0.2 over 1 when you're doing graphs. But last one. Negative 1/5 divided by 2 is negative 1/10 x. And 5 divided by 2 is 5/2. Fractions are our friends. All right? Okay. On the paper I handed out that is in front of you, you will see these 2 graphs. So just to jog your memory, the first graph was from a water tank that was losing water. So you might recall that problem from earlier in the unit. And the second one, the one on the right is, remember that fancy snack, figs and almonds. Right? It was $6 per pound of almonds, $9 per pound of figs. They spent $75. So that's, you see more on your sheet in front of you. You need to answer those questions about the situations, please. And then we'll go over them. I want to need your help with this because I want to keep this view up of the graph. So I need someone in here to help read the questions so I don't have to change slides. So Bob, you look like a guy who can read. So, what's the first question on there?
The first graph represents n equals 450 minus 222, which describes the relationship between gallons of water in the tank.
So again, this is A, total amount of water in the tank is equal to 450 minus 20t. T is time. So what do we need to answer about it?
Where on the graph do we see the 450?
Yeah, so where's the 450? Can you tell me, Bob?
Yeah.
Where is it?
It's on the top here.
Yeah, so this spot has a special name. It's actually the y-intercept. Yeah, okay. And in context, this is how much is in the tank to start, right? Okay. Who can tell me where they see that negative 20? Because I'm sitting here thinking, man, we're in quadrant 1. It's all positive. Where you see negative 20, Hadley?
It goes down by 20 every minute.
Oh, we're losing 20 liters a minute? So down 20, that's what would this be called then? My slope. And down 20, it's going down, okay? It's going down and maybe even it might even be yelling timber. Like Kesha. Okay, so down 20, right 1 will get us back to the line over and over. Down 20, right 1. Now, the next situation is a little tougher. Am I getting this one right that it is $6 per almond and $9 per fig for $75? Am I recalling that right? So this one says, where's the 6, where's the 9, where's the 75? And I'm like, it's only going to 14. It's only going up to 10. What the junk? Okay? Micah, what are you thinking?
The 75 is the total.
Oh, so that means 75 is the line, right?
Right.
Okay.
And then the 8 and the 9.
The 6 and the 9.
6 and
Yep.
the 9 are one of the ordered pairs in.
So let's check that out. 6, 9 is right here.
Are the things you multiply. The
Okay.
ordered pair by.
The things you multiply by. Now, here's one thing I'm going to say. It's right here. But it is harder to see this one. Here's why. Because there is no 0.69 or 96. This is saying $6 per pound of almonds. What's the easiest way to find how many almonds when we have standard form? If we have how many figs? Zero figs. If we have 0 figs, how many almonds can we buy? 75 divided by 6, which is right here. 12 and a half. So that is what we can see from the equation. If we're going to buy only figs, I got $75 to buy $9 a pound figs. How many figs can I buy? 8 1/3. That's what. Yeah, you're really close. So even though it's not like slapping you in the face, here's this number right here on the graph. What is pretty easy to grab from the standard form? It's pretty easy. What are these called? These 2 points that I just grabbed.
Ordered pairs.
Well, there are ordered pairs, 12.50 and 0, 8 1/3. Yeah. Intercepts. Does this one have both intercepts just slapping you in the face? Nope, just one. The 450's right there. Okay. This one, if I go all almonds and I go all figs, boom, right there. So it's there. You just have to look a little deeper. Okay, it's like an onion. You got to peel back the layers. All right?
Like an onion.
Hadley's saying we can get this to be the other form because maybe we want to look at the relationship of how it's changing the number of figs we can buy.
So you subtract the 6A.
Yeah.
Why is it? And then you divide because that's the x and you divide the y.
So, and then what am I going to do, Hadley?
So after you subtract the 6A, you divide by 9.
Yeah.
To get y equals 8 1/3.
Yeah.
Minus 2 thirds x, which is
A in this case. Does this look familiar to anybody?
no.
Where'd you see this today? It's your warm-up. That was intentional. And let's talk about what we see here. This is if we get only what?
Figs.
Only figs, because that means 0 almonds. What's anything times 0? 0. And what this is saying is the number of figs I can purchase goes down 2/3 of a pound every time I buy almonds. Do you remember yesterday the carny rides and games and you looked, same thing. It's all lines, it's all related. Big ideas are what we're going to use. You can't memorize every little thing to do. But if you wanted to get almonds only out of this, it would not be that nice because you'd put 0 in for how much figs you want and you'd have to do some stuff, right? Are you guys seeing that? If I put 0, now if I put 0 in for almonds here, all I have to do is divide by 9. So that's why standard form's great for intercepts. Slope intercept's great for one intercept and how it's changing. So on the back page here, we're going to practice altering our equations. Remember, we can make equivalent equations by doing what? Equivalent equations by same thing to both sides. I might have said that a few times the last week or two, okay? Yeah, like a lot of times. Every day, right? So you're going to work on doing that. What form are these in currently?
Standard.
Yeah, we know they're in standard form because x and y are on the same side. If I want to pick out a slope and a y-intercept, what form do you think we're going to be looking to use? Slope-intercept form.
X-intercept.
Well, there isn't x-intercept form, but x-intercepts and y is 0. The slope-intercept form almost always because it tells you how the dependent variable is changing, which is usually the thing that's changing. All right, so we're going to get after this slope-intercept form so we can grab a slope and y. And you guys know why it's called slope-intercept form, did I tell you? No, it's because there's a guy in like 500 BC, and his name was Slope-Intercept, and he discovered this. So they named it. What do you guys think?
You get the slope and one intercept.
Oh, there's a slope and an intercept. That makes more sense than that story I heard about the guy named Slope-Intercept. All right, let's find it. Going over number 1 real quick. If I'm trying to get in slope-intercept form, that means I'm isolating y. Okay? So, how do I get rid of plus or minus 4x? Plus 4x. I shouldn't hear any conversation right now. Okay? I did the same thing to both sides. How do I undo times 3? Divide by 3. Which means y equals 4/3 x plus 1. So, in our context, the thing that happened over and over, so draining by 20, was the slope. So, what's the slope of this? 4/3. It's 4/3 x. Slope is what's happening over and over, right? So my slope's 4/3. What's my starting point? 1. My y-intercept. When x is 0, y is 1. That's my y-intercept, also known as b. Y equals mx plus b. M is always slope. B is always y-intercept. All right, so 2, 3, 4, and 5. Let's go. Get y alone. I'm going to ask for some help for problem number 2. I'm looking to get y alone. What's the first move, Tess?
You do the, wait, which one are we on?
12x minus 4y equals 8. I want to get y alone. What's my first move?
So, minus 12x.
Minus 12x. If I do it to both sides, I have an equivalent equation. Negative 4y equals 8 minus 12x. Okay, now what, Tess?
Then you do divide by negative 4.
Divide by negative 4. And so y equals negative 2 plus 3x. And what this tells me is the thing happening over and over is the slope of 3. And the starting place is the y-intercept of negative 2. Get y alone, you'll have the slope and y-intercept every time.
Wait, so what letter is it?
I don't know, whatever's got a slope of 3 and a y-intercept of negative 2.
There is none. Oh, wait, yeah.
It's E. Okay, 8x plus 2y equals 16. Asher, you help me. What am I going to do first to get y alone?
Subtract 8x.
Yep, I'm going to do it to both sides. So 2y equals 16 minus 8x. Now what?
Divide by 2.
Divide everything by 2. I get y equals 8 minus 4x. The thing happening over and over is my slope. So a slope of negative 4. My starting place is my y-intercept. Right? When x is 0, what happens to this whole term? 4 times 0? 0. So when x is 0, y is 8. That's why that's always going to be the y-intercept. Cool. So negative 4 is slope. 8 is the y-intercept. Which one are we on now? 4. Negative x plus 1/3 y equals 1/3. Will. I'm getting y alone. What's my first move? So you could maybe divide, but it won't be the most efficient. We've been getting rid of the x term first time every time here. So how am I going to get rid of that negative x? I'm with Will. How am I going to get rid of that negative x? Add x. And if I do it to both sides, I'm equivalent. So I got 1/3 y equals 1/3 plus x. Well, how do I get rid of times 1/3?
Times 3.
Well, 1/3 times 1/3 is 1/9. So let's readdress.
Oh, wait, no. Divide by 1.
Divide by 1/3, which is multiplying by 3. Right? We're going to multiply by the reciprocal, but that is divide by 1/3. Okay? And that's going to give me 1 plus 3x. So what's my slope, everybody?
3.
3, and my starting point or my y-intercept? 1. Last one! Raymer, help me out here. What am I doing first?
So you're going to add 4x,
Yeah?
and then you're going to divide by 3,
Got it.
and then you do that.
What's the thing that's happening over and over? 4/3. And where am I starting? Negative 2. Slope-intercept is great for finding the slope and the intercept. There's no person, just to make sure you're clear, there's no Lord slope-intercept or something like that, okay? I made that up. All right? There's not really a person named slope-intercept. Okay. Yeah, I know, it's a bummer. You're like, my whole life's a lie. I can't trust anything Mr. Max says now. Okay, so can we find intercept from standard form?
Yes.
Can we rearrange to get in slope-intercept form? And this gives us tools in the tool belt for a variety of strategies depending on what we need to find. Cool it down, baby. Cool it down. When you're done, come up to the dot cam and grab the homework.